Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching how to get 60 out of 60 in KCET Physics. So we are continuing with the concept that we have started in our last week, that is current electricity part 3. In this part we are going to discuss mainly two concepts, that is Kirchhoff's law and Wheatstone bridge. So if you have not yet joined our WhatsApp group, I request you, please join our WhatsApp group. The link is given in the description below. Every week on a Sunday, we are doing KCET Premier League, that is KPL, and we are giving you 30 questions, and you are supposed to answer them throughout the day during your free time. Once the exam is over, Sunday evening, we are giving you the solution to the all 30 questions. So if you have not yet started attending those sessions, please join our WhatsApp group. Okay, in our WhatsApp group we are also supplying you, whenever we are uploading a video, you are getting the latest updates on all the subjects on which we are doing videos, and whenever it is updated, that will be given to you on our WhatsApp channel. So I request everyone, please join our WhatsApp group. And so let's start with today's topic. Today we are, as I told you, we are continuing with current electricity part 3, and here we are talking about Kirchhoff's laws and Wheatstone bridge. So nothing else. There was some application of Wheatstone bridge was there, but those are now deleted. So you don't need to worry about too much if meter bridge is there or any other different variations of meter bridges are there. No, they are no longer there. They are deleted. So if you don't need to worry about it. If some question comes from those chapters, they will be definitely considered as deleted, like that happened in 2024 exam. So focus on mainly Kirchhoff's laws and Wheatstone bridge. Now, what is Kirchhoff's laws? There are two main rules of Kirchhoff. Okay, and mention you pronounce it as Kirchhoff or Kirchhoff. Both are okay. Okay, Kirchhoff's laws or Kirchhoff's laws or Kirchhoff's rules, both are okay. Okay. Now, first law is called junction rule. Okay. Also, sometimes some books, some teachers, they refer it as KCL, Kirchhoff's current law. Okay. KCL means Kirchhoff's current law, or junction rule, as mentioned in your NCERT book. They are calling it junction rule. In many foreign books and as well as in Indian books, good well authored books, they mention this as KCL. So if you are reading KCL and you are thinking what is this rule about, don't worry, this is same as junction rule. This is nothing new. Now, what is the junction rule? At any junction, the sum of the current entering the junction is equal to the sum of currents leaving the junction. So let us understand the meaning of this. Suppose I have a junction. Junction means where, what is the meaning of a junction? You know, railway junction, right? Bus junction. So railway junction means where multiple lines meet. Okay, so one from from Mumbai, one from Telangana, one from Andhra Pradesh, one line within Karnataka also. So if multiple lines converge it at one single station, we call that station as junction. So junction means where multiple lines meet. Similarly, in current electricity, suppose I have a circuit, okay, and at some point multiple currents are meeting at a point, then this is called a junction. Junction means where multiple currents are coming from different lines and they are joining at some point, then this is called a junction. Okay, this is a junction where multiple currents are meeting. Now, suppose current I1 is coming in, I2 is coming in, I3 is coming in, whereas current I4 is going out and I5 is going out. So according to junction rule, total current in should be equals to total current out, right? That means I1 plus I2 plus I3, these are all coming in. So these are the total current of all the currents that is coming into the circuit. Now that should be equals to the current that is going out, that is I4 plus I5. Simple law, nothing complicated. But when you are applying, sometimes it may be a little difficult. Sometimes you might feel, okay, this may be little difficult, but don't worry too much. It is not super hard, not super difficult. when you are applying this law alongside next law that we are going to study, so sometimes it may be become little bit complicated, but don't worry, it is not super complicated if you apply little bit logic. Okay, there will be no very difficult questions will not come in your exam. Okay, now one important concept is that, so basically what is the meaning of that? If you can say the current is basically charge per unit time. So if you consider all the times, unit time, so q1 by t plus q2 by t plus q3 by t, so we can write this as current is charge by time, so q1 by t, q2 by t plus q3 by t, that is the total charge coming in, and this is the total charge going out. Or in the other sense, we can write q1 plus q2 plus q3 should be equals to q4 plus q5. That is, total charge coming in is equals to total charge going out. What is this law about? This is conservation of charges, right? This is conservation of charges. So basically, Kirchhoff's current law is nothing new. It is only a modified version of conservation of charge principle, right? So this is a direct consequence of conservation of charges principle. So you already studied about conservation of charges. Charges cannot be created or destroyed in an isolated system. Total charge remain constant. Same thing can be said about current, because current is basically charge per unit time. So if you take the charges per unit time, total charge should be constant. Now let's move on to the next law or next rule, which is loop rule. Okay, sometimes it is also called KVL, Kirchhoff's voltage law, or KVL. Okay, and in common terms it is called loop rule. Loop rule, as the name suggests, it is associated with a loop. Okay, the algebraic sum of changes in the potential around any closed loop involving resistors and cells in the loop is 0. Okay, so suppose I have a circuit. Let us consider a simple circuit. Okay, the current in this branch, say I1, in this branch, say I2, in this branch, say I3. Okay, then same current will pass through this as well. Okay, now what is Kirchhoff's voltage law says that if you take any one isolated loop, okay, any one loop, that means if you start, say A, B, C, D, this is one loop. Okay, A, B, C, D, A. This is one loop. Again, B, E, F, C, this is another loop. So if you consider any one loop, okay, and consider all the potential drop across the each components, then total potential should be 0. So what is the meaning of that? So what is the suppose this resistance is R1, this is R2, this is R3, this is R4. Now let us consider ABCD. Okay, the loop ABCDA. So the way of writing a loop is you start from a point, okay, A, then you continue the loop. Next point is B, okay, next point is C, next point is D, and then you again have to end it at the starting point. So A, B, C, D, A. The way you write your rectangle or parallelogram, same way, but here, since we are closing the loop, you have to end it at the starting point. This is a way of writing the name of the loop. Okay, this is the way to write the name of the loop. Now, if you consider what is the potential drop across this resistor, potential drop across this resistor is I1 R1. Okay, now we are moving in the direction of current. As long as we are moving in the direction of current, potential drop across any resistor will be positive. Okay, you need to remember that. So here also we are starting from A, so you are moving in the direction of current, right? So you are moving in the direction of current means this will be positive. Again, we are moving in the direction of current, shown current. Maybe it will come out to be negative, but for now we are assuming current is flowing in this direction only. So in this case, I2 R2, right? Now here, to move from C to D, which direction you are moving? suppose this is epsilon 1, this is epsilon 2 source. Okay, generally nowadays we started representing the EMF as epsilon, right? Not no longer V. Okay, V is also fine, but we have matured enough. Now we are using the symbol epsilon. So we are using some of the other symbols. Now epsilon is the potential of the battery, right? Now what is happening when we are going from C to D? Look, we are going from negative of the battery to the positive of the battery. So negative of the battery to positive of the battery means it will be minus epsilon 1. Okay, this should be equals to 0. This is the meaning of Kirchhoff's voltage law. So remember these 3 points when you are moving in the direction of current, when you are considering a loop, any loop. Okay, if you are moving in the direction of current, okay, the voltage drop across any resistor is positive. When you are moving, while you completing the loop, if there is a battery involved or a cell involved, when you are moving from negative of the cell to the positive of the cell to complete the loop, then the voltage drop will be negative. If somehow if you are moving from positive of the loop to the negative of the loop, then the voltage drop will be positive. You have to remember that. Okay. One other thing that you can do, that all the voltage drop you are considering then equals to potential difference, that is also okay, but maybe they will involve you more than one battery, maybe they will give you more than one battery at different points, okay, and then you will be confused which one will be positive, which one will be negative. So don't get confused. You use this loop law that I am teaching you, that if you are moving from in the direction of current, voltage drop will always be positive in a resistor, and if you are moving from negative to positive of the battery, it will be negative. In case if you have taken, suppose for example, if you have taken this loop, okay, A, D, C, B. So suppose same loop I am taking in the opposite direction, A, D, C, B, A. So I am starting from this point. This is also a loop, right? This is also a loop. Now what will happen in this case? In this case, see, we are moving from positive of the battery to the negative of the battery. So first epsilon 1 will be positive. Now in this case, we are moving from C to B. So we are moving in the direction opposite to that of the current. So it will be minus I2 R2. Here we are moving in the direction opposite to that of the current, B to A. So it will be minus I1 R1, and that should be equals to 0. Now tell me, what is the difference between these two equations? Only thing that is difference is we have multiplied this with a negative sign, right? So nothing to worry about. If you are following the steps I am teaching you, then you will be never be wrong. Now to solve such kind of questions, KVL is not sufficient. You have to apply KCL as well. So you have to take two loops. You have to apply KVL as well as KCL, and then simplify it to get an answer. But in most of the competitive exam, they don't give you these lengthy problems. They will give you some tricks, okay, problems that involve some tricks, and if you apply those tricks, the problem will be very, very easy. Now one more thing is that this law is direct consequence of the conservation of energy principle. So this law KVL comes from conservation of energy, KCL comes from conservation of charges. So if this question comes in your maybe PU board, maybe KCET, that which of the following law is direct consequence of conservation of energy, so then you have to write loop rule or KVL. Okay, both are synonymous, both can be used, any one can be given as an option. So you have to be careful. Kirchhoff's voltage law, they will mention, they will not ask you KVL, they will give you Kirchhoff's voltage law or Kirchhoff's loop rule. Okay, so you have to be careful which one you are answering. Loop rule or KVL is consequence of conservation of energy, okay, and junction rule or KCL is direct consequence of conservation of charges. These two things are very, very important. Now let's look into one example. Very common example. We have a cube like this, and the question is, each resistance is given cubical network has a resistance 1 ohm and the equivalent resistance between A and B. So they have given you a cubical shape, and they have asked you to find the resistance of this combination, okay, and they have given you values all the values. Now you have to decide which one is the correct answer. Now how you can solve such questions? There is a solved example in your book as well, but you may be wondering how we can solve this question and what is the way. Now first of all, you should remember that this problem is easy only when all the resistors are equal value. If they give you a non-equal value, then it will be very complicated and very long answer. Okay. Otherwise, if they give you equal values, most 99.99% cases they will give you equal values. Okay. Otherwise, if you are seeing okay they are not equal, then they require some extra effort, some longer methods. Okay. Otherwise, you need to remember that you are starting here, your starting point is here, and you are starting here, ending here, right? So this is your starting point A, this is the starting ending point B. Now you have to see how you can reach from A to B. What are the possible ways? So if you start from this way, there are multiple ways possible, but you have to find the shortest way to reach starting from A and reaching B. So one of the shortest way is start here, go here, go here. How many resistances are there? 1, 2, 3. Okay, this is one way. Another way, can you think of another way? You start here, you go here, you go here. Okay, again 1, 2, 3 resistance. Other possible ways, you can start here, you can go here and go here. Now how many resistance? 1, 2, 3. Any other possibilities? Yes, there are other possibilities as well. You can go here, you can go here, you can go here. So any path you take, either you take via this route, you take via this route, or you take via this route, always you are reaching point B with the minimum resistance rule. Okay, there is a law called minimum resistance path. Current always travel in the minimum resistance path. If you see minimum resistance, you have to overcome 3 resistors, right? So we can say all 3 paths starting from all 3 parts where it is starting, that from A, all the parts are equally resistive, that is they are symmetrical. Okay, all 3 paths starting from A. So from A we are having 3 paths. This is one path, this is second path, this is third path, and all paths will have 3 resistors that you have to overcome if you want to reach point B, right? So what we can say, they are all symmetrical paths. Now what we know about symmetrical paths? Suppose I assume the current here as 3I. Why 3I? I will just explain in a while. So there are 3 paths all identical, and if total current entering the point A is 3I, then this 3I current will be equally divided, I. Junction rule. Okay, incoming current should be equals to outgoing current. So incoming current is 3I, outgoing current should also be 3I. Now since they are identical paths, it does not matter which path you take, you always reach point B after crossing 3 resistors. That's why we can say they are identical paths, and we can say they will all have I current. So basically, since we have 3 identical paths, I have taken the current 3I. This is a smart way of solving this kind of problem. In case only 2 paths are there, I would have taken the current as 2I. If there is only one current path was there, I would have taken the current as I. Okay. Now, after reaching this point, suppose this I current is going, right? After reaching this point, now how many possibilities are there? So say again, if you see from this point, I have already shown you, this is one path, this is another path, right? Both paths have 2 resistances each. So again, this I current will be divided into 2 halves, that is I by 2 and I by 2, right? Now again, after reaching this point, okay, at this point what will happen? All the currents I will be converging. Okay, all the currents will be again I. Similarly here in between resistors, they will all have I by 2 current by symmetry, right? And the ending current, starting will be I, ending will be I, in between it will be I by 2. Okay, because if you see this circuit, it is not easy to understand whether it is series or parallel or any other combination. So whenever we are not able to apply the law of combination of resistances, we will apply KCL and KVL. Even in case of where you can apply law of parallel combination and series combination, you can apply KVL and KCL, but in that case, if you can find the equivalent resistance and find the current, then that will be a much easier method, right? But whenever you are not able to apply that law, that case we will specifically apply KCL and KVL, because KCL and KVL can be applicable to any circuit. Okay, it does not offer any restrictions. It can be applicable to any circuit wherever you are considering current is flowing through a closed loop. Now, what we will do, we will consider, if we can find the current I, basically 3I, okay, then we can find the equivalent resistance. Okay, this is one way that we know that V equals to IR. Okay, if we can find the current I, 3I basically in this case, then we can find the resistance. Suppose here I am writing 3I, so R will be actually V by 3I. Now you will say, sir, what is V here? This is an external circuit, right? So I can assume there is a voltage source connected here, and for simplicity I am assuming this voltage source is V. Okay, so we just need to find the current I, then we can find this relationship, and then we can find the current. Now, how we can use this concept and find the current? So first, this voltage source we have externally applied. Now, if you take this path, any one of the path, if you take any one of the path, we can find the apply the KVL. So first of all, we are starting here. Current distribution, if you understand the current distribution, rest of the problem is easy. So we started here, again here, here, this loop we are considering. Okay, so this loop, say, let me name this loop so that it will be easier for you. A, B, okay, C. This is not B, because B is already there, right? This will be B. Okay, so let me assume this is P, this is Q. Don't go into A, B, C, D, it will be confusing. So what path we are following? We are following A, P, Q, B. This path we are following, and again we are coming back to A. Okay, so from the path A, P, Q, B, A. Don't worry, the notes will be provided after end of the lecture, so you can check the solution again. So from that path, what we can do is we can find the currents. So what is the current? Suppose this resistance is R. This is also R. All resistances are equal value. That is 1 ohm. For now, we are assuming they are all R. Okay. So here it is IR. Here it is IR by 2. Here it is again IR. So what we can write is IR plus IR by 2 plus again IR minus V should be equals to 0, right? Now if you multiply them, what is the value? You will get 2 IR plus 5 IR by 2. Okay, you just need to add it. Okay, 1 plus half. 1 plus 1 is 2, plus half is 5 by 2. Okay, equals to V. Right? So 2V by 5 is IR. Now what was our target? I already told you. If we know that total current in the circuit is 3I, and if the R equivalent is R, okay, then that should be equals to V. So what is our target? Our target is to R equivalent should be equals to V by 3I. That is our target, right? That is the equivalent target, equivalent resistance. Now from this equation, we can calculate V by I. So first calculate V by I. R is given 1 ohm. So I times 1 to V by 5, right? Or 5I equals to 2V, right? Or 5 by 2 equals to V by I. So V by I is 5 by 2. Put the value here. 5 by 3 times 2, that is 5 by 6 ohm. This is the equivalent resistance. So we have combined KVL, Ohm's law and junction rule one by one to calculate the resistance. So correct answer is 5 by 6, that is option number C. Okay. If this same problem is given to you, you should remember the value 5 by 6 and you can answer it. But in case they have given you instead of 1 ohm, if they give you 2 ohm or 5 ohm, all the resistances are of 5 ohm, then how you can answer that question? So I am giving you a homework, bonus homework question. There will be homework question definitely, but a bonus homework question. Suppose this value of R is 5 ohm. Okay. Then what is the value of R equivalent? Tell me the answer. How you can modify this formula to, basically that will be a shortcut method, shortcut trick for you to answer. I will not going to discuss that during our lecture. I will while solving previous year questions, I will be giving you a hint. Okay. Now let's move on. We are now discussing the homework problem that I gave you on Friday. Okay, what was the homework question? 10 identical cells, each of potential E and internal resistance R, are connected in series to form a closed circuit. An ideal voltmeter is connected across 3 cells. Okay, so 10 cells, each of them are connected in series. Okay, potential difference is E and resistance is R. Such 10 circuits are connected. Okay, I have to draw 3. So there are 10 such circuits are connected, and they have asked you what is the reading of a voltmeter when you connect it across. They are all connected in series. Okay, so they are basically closed loop. Now what is the voltage drop across 3 volt battery if you connect them in this way? Okay. So this is the reading. What is the reading of this voltmeter? That you have to calculate. Now to calculate that, what you have to do first, when the voltmeter is not connected, what you have to do, you have to find the current in the circuit. They are connected in series, right? So they must have connected end to end, and then they must have connected, right? So series connection means there are no external resistance. External resistance is not connected. The only batteries are connected using their internal resistances. Now what is the total potential? Total potential should be E1 plus E2 plus E3 plus E4, right? That is the series combination. So total potential difference is 10E. And what is the total resistance? Total resistance should be equals to R1 plus R2 plus R3, that is 10R. Each of them has equal resistance. Now what is the current then? Current in the circuit, no external resistance is connected, so current will be, right? So epsilon is 10E divided by 10R. So current is E by R. Right? Now when you connect the voltmeter, how many circuits are there? How many batteries are there? 3 batteries are there, 3 resistances are there. Now we know that external terminal voltage is given by 1, 2, 3. 3 batteries are there, so 3E minus 3 RI, right? 3R. 3R means R1 plus R2 plus R3, right? So all 3 will be added. So if you remember, terminal voltage across a battery was epsilon minus IR. Okay. Now here we have 3 potentials, 3 sources and 3 internal resistances. Only thing you have to put this value. So 3E minus 3R times E by R. So it is cancelled. 3E minus 3E, it will be 0 volt. So the correct answer is 0. Okay. So correct answer is 0. This question came in 2024, but this option 0 was not there. So it was given as a bonus question. But I have corrected this question and I have given it to you. I don't know how many of you have corrected it correctly, but I have not received too many responses in this video because maybe you were busy celebrating Ganesh Chaturthi. So I hope that your festival is over and now you should concentrate on studies again, right? Not many of you are answering the homework questions. You are seeing the questions, but you are not answering it, which is not good. Okay, you cannot just only watch the video and without answering the homework question, you can leave. Next, the variation of terminal potential difference with current flowing through a cell is as shown. Okay, the EMF and the internal resistance of the cell are. So, what is the variation of voltage? So, variation of voltage, first when current is 0, voltage was 3V. We know that V equals to same formula, last formula, okay, epsilon minus IR. Now when I equals to 0, okay, V should be equals to epsilon. Now if you go back and check the figure, here I equals to 0. This line represents I equals to 0. This is I equals to 0, right? So I equals to 0 means this should be the value of potential difference epsilon naught. Now here at this point, external voltage is 0. At this point I equals to 0. This is y axis, right? At y axis x equals to 0. That is the basic law. Now what is in x axis? X axis is current. So y axis x is equals to 0, that is current is 0, and this is x axis. X axis means y equals to 0. Y is volt. So voltage should be 0, right? Now, and what is the current? Current is 6 ampere, right? So at when voltage equals to 0, so we can write this as 3 volt. So the voltage of the battery is 3 volt. Okay. Now current is 6 ampere, right? So 0 equals to 3 minus 6 times R. So R should be equals to 3 by 6. That is half ohm. Okay, or 0.5 ohm. Now what are the options? So in the option given 0.5 ohm, 3 volt. So that is correct option is option number D. Okay. Now if you have understood this question, mention that in the comment below. Now let's move on. Wheatstone bridge. It is not the bridge that you see in the river Tungabhadra or in Kaveri. It is not that kind of bridge. This is a bridge of current. Okay, it is bridging currents. It is not bridging to land. Okay, bridge always means that which we see while traveling in a railway station or while driving in a city. Okay, that is not the bridge. Okay, someone may be seeing, oh, electronic city flyover bridge. No, not that bridge. Bridge is when you are connecting to unconnected pieces, that is called bridge. Okay, in this case we are connecting to current. That's why it is called bridge. And Wheatstone is the name of the person. It's nothing related to wheat and stone. Some people remember it by that, wheat and stone, but it is nothing to do with wheat and stone. In common terms, the chakki that we say is not that thing. It is a name of a person. Okay, Wheatstone was the person who first developed this concept, and at say around 60-70 years back, 50 to 60 years back, this was very widely popular and used extensively because it was main thing that is used in telegraph. Okay, telegraph. You used to say send telegrams. Okay, maybe you have studied that in your English class. how to write a telegram. But telegram is no longer useful. It is obsolete today. We have mobile phones, so telegram etc. are no longer needed. In fact, Indian Post has discontinued telegram completely. Telegram was a service that was used extensively to send messages across countries, across borders for different places. So that was during that time it was very popular. Okay, Wheatstone Bridge. Now, in fact, there was something called a post office box. Post office box is nothing but the box where you deposit the letters. Post office box was an application of Wheatstone Bridge, which is no longer in use, which we do not use. But this concept is very essential to understand a complex mechanism. Okay, if you study physics in future, physics honors or major physics major, then there will be unbalanced Wheatstone Bridge, where you are treating this completely new and you will solve a different complex kind of problems. But we are not interested in that. We are solving how the Wheatstone Bridge can be balanced. The derivation is there in your PU. I am not going to do the derivation right now. What I am going to do is, what is the meaning of balanced Wheatstone Bridge? That I am going to explain. What is the meaning of balanced Wheatstone Bridge? So, balanced Wheatstone Bridge means when this entire system is balanced, okay, this structure is called Wheatstone Bridge. Okay, this structure. Okay, so there are 4 resistors like this, and there is a galvanometer connected in between. This structure is called Wheatstone Bridge, and the current, if somehow we can make the current through this galvanometer equals to 0, somehow adjusting the resistances, if we can adjust such that the current through the galvanometer is 0, then we call this is a balanced condition. Okay, in balanced condition, current through the galvanometer is 0. Now, when current through a resistor or any component becomes 0, think, suppose I have a resistor connected to a battery or something, some 2 parts are connected, say this is A, this is B. Now, when the current through this resistor becomes 0, if I directly connect it to a battery, will it be 0? What Ohm's law says? Ohm's law says there should be a current, but when it will be 0? Think, pause the video. I am going to answer it in a while, but pause the video honestly and answer that in the comment. When do you think current through a resistor becomes 0? When do you think current through a resistor becomes 0? Done? Answered? Okay. Now, current through a resistor becomes 0 when potential at both of its ends are equal, right? So, whenever there is a potential difference, current flows. That was the Ohm's law. So, if you apply a potential difference across a resistor, there will be a flow of current. But if we apply potential at this point, say V, and if we apply the same potential other end as well, V, then both ends will have equal potential. So, equal potential means potential difference will be 0, potential difference 0 means there will be no current flowing in that circuit. So, if VA, this is VB, and this is VD. If somehow by arranging the resistors, arranging the current such that if VB becomes VD, then in that condition the current through the galvanometer will be 0. Okay. So, first thing, what is the balanced condition? Balanced condition when there is no current passing through this galvanometer, and when it is happening when these 2 potentials are equal, that is VB equals to VD. If these 2 conditions is achieved, then we say the Wheatstone Bridge is in balanced condition. Now, when we can say this balanced condition? The balanced condition can be achieved when Ig is 0, right, and the corresponding condition in terms of resistances is R2 divided by R1 equals to R4 divided by R3. Okay. Sometimes this formula has different types of variations. Okay, I will give you that variation as well. The variation is, if we write R2, some people write it like this, R2 divided by R4. Since this is a proportional equation, this is also correct, equals to R1 divided by R3. This is also correct. Okay. In some books, some notes, some external notebooks, they use this as PQRS. Okay, and they mention that the formula is P by Q equals to R by S. That is also okay. R1, R2, whatever formula you are using, whatever form you are using, as long as you are using in a order, it is fine. Okay, P by Q equals to R by S, or P by R equals to Q by S. Everything is okay. Okay, as long as you are using them in proper order. Okay, you cannot use P by S equals to R by Q. That is not correct. Okay, only thing, either this by this equals to this by this, or this by this equals to this by this. Okay, you don't need to remember the formula, only you need to draw the diagram and remember top by bottom is equals to top by bottom on the other side. That's it. Okay, now this is very simple formula, simple equation. Derivation is also simple. You must practice the derivation for your PU board, and when it comes in exam, they make the circuit little bit complex. Okay, this is also one of the previous year questions. They will give you a circuit looks like this, and they will tell you, this is also 2024 exam, by the way. This also came in 2024. Now, how you can solve this question? You will think, okay, this is maybe series and parallel combination or something, but actually it is a Wheatstone bridge. This is nothing but a Wheatstone bridge. How you can say this is a Wheatstone bridge? If you see this point and this point are connected. So, let me redraw this with starting say 1, okay, this point say 2, this point say 3, this point say 4. I am doing it for this part first. If you see, this part and this part look exactly same, only here we have R's and here we have 2 R's. Okay. So, here we have R's, and we can simply redraw this diagram as starting from 1. Okay, I am starting with 1, and this resistance I am drawing it like this. Okay, this resistance. Now, this resistance I am drawing it like this. This is point 1. Okay. Now, this resistance is ending at point 2. Okay. Now, which resistance starting at point 2? There are two resistances starting at point 2. One is this and ending at 4. So, where is that going? Let me draw this and say this is point number 4. This resistance, and I said this is point number 3. This resistance running between 2 and 3. This resistance running between 2 and 3. Okay. And this resistance is running between 3 and 4. This resistance is running between 3 and 4. Okay. So, basically what you see, this is a Wheatstone bridge. Now, all the resistances are R. So, R and R. Now, if all the resistance are equal, definitely Wheatstone bridge condition, balance condition is valid, right? So, R by R equals to R by R. Obviously, R by R is 1, here also R by R is 1, so both side is equal. So, in this case, there is no current passing through this resistor. Now, what is the meaning of that? If there is no current passing through a resistor, what we can do? No current passing through this, right? So, no current passing through this means we can simply do this. No current passing through this, right? So, whenever there is a no current passing through, that is Wheatstone balanced condition, we can simply remove the middle resistor. We can simply remove the middle resistor as there is no current passing through this one. Similarly, if you consider this resistor, we can cancel the middle resistor. So, middle resistor will be cancelled. Now, once middle resistor is cancelled, now what is the circuit looks like? If you see this condition, this circuit. So, Wheatstone bridge is only conceptual. Once this is over, only thing is left is for you to apply the series and parallel combination of resistors and solve it. Okay. Now, if you see, these two resistances are in series. Okay. These two resistances are in series, these two resistances are in series, and then the entire system is in parallel. So, R and R are in series, that is 2R. So here also R and R in series, so 2R, 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 2R in parallel. 2R, 2R in parallel means what is the equivalent resistance? I said when two equal resistances are in parallel, the equivalent resistance is nothing but 2R by 2, that is R. So the entire system is basically one resistance of R. Now if you understood this part, tell me what is the total resistance of this part. All the resistances were R. After applying Wheatstone bridge formula and applying series and parallel combination, we calculated the equivalent resistances for this part is R. Similarly, if we apply the same concept and find the equivalent resistance, this part will be nothing but 2R. So R plus 2R is the equivalent resistance of the total part. So total resistance is basically R plus 2R, that is 3R. So 3R is the total resistance of this combination. Now 3R is the total resistance. Now what is the potential difference? This means potential difference is 0. At this point potential is 0. So potential is 0 here, V naught is here. So what is the potential difference? V naught minus 0 divided by 3R. So that is V naught by 3R is the current. So V naught by 3R. So correct option is option number D. Okay. So now we have reached towards the end of our lecture. So as usual, I am giving you 2 homework questions. You can pause the video here, note the questions and solve it, or you can download the lecture notes and you can solve it from there as well. Okay. So this is the first homework and this is the second homework. Second homework is little tricky. Try to answer them and mention the answer in the comment below. I will try to answer if you are answering it correctly or incorrectly. I will mention that your answer is correct, your answer is incorrect. And tomorrow I will be back with the solution of these 2 questions as well. Not tomorrow. Tomorrow we are going to do previous year questions of this chapter. Very, very important chapter. As you know, 6 to 7 questions coming from this chapter. So don't miss on the PYQs of this chapter. It's very, very important if you are preparing for KCET 2025 exam. So tomorrow I will be doing previous year questions. Day after tomorrow, okay, that is Wednesday, we will be solving these 2 questions while starting the next chapter. And we have a dedicated playlist available in our YouTube channel. If you are facing difficulty to check the videos or revise the videos that you already done in our channel, everything is available in one banner. Okay, KCET 2025 Physics 100-day challenge. Okay, 100 within 100 days we are going to complete all the chapters. Okay, all the chapters, all the concepts we will be completing in 100 days. Already I think it is the second week going on. Second week is completed and third week is going on. So maybe in few more weeks I will be completing everything related to your physics. So don't worry about physics anymore. I am here to help you, and for that you have to join our WhatsApp group. Every week we are going to give you a question paper. We are giving you a question paper. Already 2 sets of exams is over, and if you have missed them, mention that in the comment below also, that I have not been able to answer the question paper yesterday. Why it was so, that also you mention. Okay. So I will be seeing you in our next video tomorrow. And if you have not yet subscribed to our channel, don't forget to subscribe to our channel. Thank you for watching.